So let's cut through the hype together and look at what's actually changing. You can see it in the way engineers lean forward at their screens, watching something they've waited decades to witness. Humanoid robots are learning to move like us. And here's what most people miss about this moment. The breakthrough isn't really about better motors or stronger joints. It's about a fundamental shift in how these machines are taught. For the first time, robots are learning by watching, the way a child learns by observing a parent tie their shoes. If you felt uncertain about where technology is heading and how it might reshape your work, you're not alone. The ground is shifting fast, and it's hard to know what's signal and what's noise. Picture a laboratory with white walls and fluorescent lighting humming overhead. A humanoid robot stands at a table covered with scattered objects. Cups, tools, fabric. A researcher demonstrates folding a towel. The robot watches. Then it tries. A year ago, that robot would have needed thousands of lines of code written specifically for towel folding. Every movement prescribed. Every angle calculated. Now it watches a few demonstrations and figures out the rest. This is where the idea of physical AI becomes crucial. We've spent years teaching artificial intelligence to process words and images inside computer screens. Now that same learning approach is spilling into the physical world. Robots are developing what researchers call embodied intelligence, the ability to understand and interact with messy, unpredictable reality. Think of it like this. Traditional robotics worked the way a coral reef grows, slow, deliberate, building structure piece by piece, according to fixed instructions. Physical AI works more like water finding its path down a mountain. It adapts. It flows around obstacles. It learns the terrain. And this isn't just academic curiosity. The implications are practical, and they're arriving faster than most industry timelines predicted. If you're building a business, creating content, or just trying to understand where opportunities are forming, this shift matters. So why is this happening now? Three forces are converging at once. First, hardware costs have dropped dramatically. Sensors that once cost thousands now cost hundreds. Actuators built for industrial machines have been miniaturized. You can see this in the sleek designs emerging from robotic startups. Machines that look less like factory equipment and more like something from a science fiction film, standing in well-lit showrooms with polished concrete floors. Second, simulation environments have become incredibly sophisticated. Before a humanoid robot takes a single real-world step, it might practice millions of steps inside a virtual world. Picture a robot learning to walk across digital terrain, mountains, ice, rubble, all rendered in software, all teaching the machine balance and recovery without risking expensive hardware. That's a massive change in who gets to benefit. You don't need to speak in code anymore. You can tell a robot what you want in plain language, and it can translate that into movement. Imagine a small business owner in a cluttered workshop, sawdust floating in afternoon light. They need a robot to sort parts into bins. Instead of hiring a programmer, they show the robot what to do and describe the exceptions. If it's rusted, put it in the red bin. If it's clean, the blue one. The robot gets it. This accessibility is the real unlock. But here's the flip side, and it's worth sitting with. When powerful tools become easy to use, they spread quickly. That creates opportunity, but it also creates competition. The same capability that helps your small business helps every other small business. Advantage becomes table stakes faster than ever before. There's also a harder question lurking underneath all this progress. What happens to human work when robots can do physical tasks with human-like flexibility? This isn't fear bait. It's a genuine tension that economists and policymakers are wrestling with right now. Some research suggests new categories of work will emerge, the way they did after previous technological shifts. Other analysis points to potential displacement that hits certain communities harder than others. This is about potential trends, not financial advice, but it's worth thinking through where you want to be positioned. Let's talk about where the real frontier actually sits. It's not just in the hardware, it's in the data. Picture a massive server farm at night. Rows of machines blinking green and amber in the darkness. Cooling fans creating a low, constant hum. Inside those servers, videos of humans performing tasks are being processed. Cooking, cleaning, assembling, repairing. Every movement analyzed, broken into learnable segments, fed to neural networks that will eventually control physical bodies. The companies racing ahead right now are the ones with access to the richest datasets. They're partnering with manufacturers, hospitals, and logistics operations. Anywhere humans do physical work that can be recorded and studied. This creates an interesting dynamic. The most valuable commodity in the next phase of robotics isn't steel or silicon. It's footage of human hands doing useful things. If you're in a position to capture and own that kind of data, you're sitting on something increasingly valuable. Here's something that might surprise you. The path to truly capable humanoid robots might not run only through big tech companies. Some of the most interesting work is happening in smaller labs, often connected to universities, where researchers are focused on fundamental problems like dexterous manipulation. Think about your own hands for a moment. The way your fingers adjust pressure when you pick up an egg versus a hammer. The way you catch something falling without thinking. That kind of fluid, context-aware movement is incredibly hard to replicate. But progress is accelerating. Researchers are now building robot hands with artificial skin that can sense texture and temperature. Picture a robotic finger pressing against fabric, sensors firing to detect whether it's silk or denim. These details matter because they're what separate a robot that can work in a controlled factory from one that can work in your kitchen. So where does this leave someone trying to make sense of it all? First, understand that the timeline is measured in years, not months. Humanoid robots capable of general household tasks are still in development. What's arriving sooner are specialized applications. Robots that assist in warehouses, robots that help in healthcare settings, lifting patients or fetching supplies, robots that handle dangerous tasks in construction or disaster response. Second, consider the skills that will remain valuable. Creativity, judgment in ambiguous situations, the ability to work with and direct robotic systems. The humans who thrive won't be competing with robots. They'll be the ones who know how to orchestrate them. Third, watch the regulatory landscape. As these machines become more capable, questions about safety standards, liability, and job displacement will drive policy debates. The shape of those rules will determine which applications flourish and which face friction. Until next time, we're going to keep following how AI and robotics reshape work, money, and opportunity, and what you can actually do about it. The next robotics frontier isn't arriving as a single dramatic moment. It's emerging through thousands of small breakthroughs, each one building on the last, like sediment slowly forming stone. The researchers know this. The investors know this. And now you know it too. The question worth leaving you with is this. Given what you've heard today, what's one small step you could take to position yourself closer to this shift? Maybe it's following the research,